That was a great introduction to coroutines. I'd like to take a moment to repeat some of the key points. Coroutines can simplify async programming by replacing callbacks. Let's write some code to make an imaginary network request. To make it interesting, we're going to start this network request on the main thread. The main thread is the thread that draws updates to the screen and handles user input. If we write our code in what's called a blocking style, where we return the result directly from network request, it will block the main thread. This is a problem because a network request takes seconds or minutes to complete, and the entire time that it's running, the main thread won't get updates. The user will see your app as frozen. When the app tries to refresh the screen with onDraw, it will have to wait until after the network request completes. This is called jank. If instead we write the same network request with callbacks, now the code won't block. Our networking library will take care of running the network request on another thread, and when the data is ready, it will call back to the main thread. The callback is the handle the library uses to pass data from the background thread to the main thread. After we get the callback, we can show the data to the user. Now, let's write the exact same network request with coroutines. It looks just like it did when it was a blocking function. However, since it's a suspend function, instead of blocking the main thread, when network request is called, it will suspend the coroutine. This frees up the main thread to go do other things like handle onDraw. And when the result is ready, it gets passed back to resume the coroutine. It's important to note that with coroutines, our networking library still uses another thread to run the networking request, just like it did with callbacks. The main difference is the code tends to be simpler than the callback version. Understanding suspend and resume is the key to understanding coroutines. Let's zoom in on what happens when you suspend. To make the example a little more interesting, I'm going to assign a variable x to the value 1. When we call a suspend function on the main thread, it gets added to the call stack just like a normal function. Since it's a coroutine, it runs inside of a coroutine dispatcher, which knows how to suspend and resume. Then the code continues like normal. First, it assigns x to 1, and then it calls another suspend function. And here's where things get interesting. Instead of adding network requests to the stack like a normal function call, onDataLoaded will be suspended. This means the current state of the function will be copied from the stack onto the heap. Then, network request will be added to the stack before it suspends itself to wait for the network result. Fast forward a couple seconds. The result is ready. The coroutine dispatcher will resume the coroutines where they left off. First, it'll resume network request. Once network request processes and returns the data, the dispatcher will resume onDataLoaded. Note that when onDataLoaded resumes, it's still in the exact same place. It doesn't start from the top of the function like a normal function call. Instead, it resumes where it left off. The local variable x is still set to 1. Our coroutine can now continue, assigning the result to a local variable and showing it to the user. By using this suspend mechanism, coroutines allow you to describe async operations using structured programming. This can greatly simplify your code. Let's take a look at a few examples of what structured programming with suspend functions looks like in Kotlin. To run two coroutines sequentially, you simply call them as if they were regular functions. Here, network request will complete, then other request will complete. And once both are done, show will be called. When a suspend function has a dependency on the result of another suspend function, you can just use variable assignment to store the result. Here, we're storing the result of a network request and using it to pass a value to another request. To signal an error, coroutines throw exceptions, which you can manage with regular try-catch blocks. And to call suspend functions repeatedly, you can wrap it in a loop. Or, if you prefer a functional style, you can use them that way in Kotlin too. Spawning multiple coroutines in parallel uses another function called async. When you call async, the coroutines run in parallel, kind of like a lightweight thread. To wait for the result of an async call, you can use the suspend function await. And if your coroutine needs to use a conditional, you can do that with an if statement. Here, we're getting the result of the first network request, and based on that, sometimes calling another request. Now, altogether, coroutines are a great way to simplify async code by turning callbacks into sequential code that uses concepts from structured programming. To learn more about coroutines on Android, check out the Code Lab using Kotlin coroutines in your Android app. Stay tuned to DevFest on Air to see more of the top talks from GDG season 2018.